Hello everyone, this is Harshit Goyal and this is my ELL101 project about how do mobile phone chargers work. How does a mobile phone charger use 220 volts AC RMS and convert it to 5 volt DC? So what are the basic steps that are involved in this transformation? A 220 volts AC input is taken and it is rectified to a high volt DC signal. The DC signal is converted to a high frequency PWM signal that stands for pulse width modulation signal, and then it is stepped down to a lower voltage, and then by a single diode rectification we convert this lower voltage AC signal into a DC signal. Now this is the 220 volt input side. Over here a fusible resistor is present. A fusible resistor is a wire bound resistor designed to burn open easily when the power rating of the resistor is exceeded. So it serves dual functions. When the power isn't exceeded the safe limit, it serves as a current limiting resistor. And when the power rating is exceeded, it burns up like a fuse, hence protecting the inner circuit from further damage. Next is the conversion of the 220 volts AC to DC signal. So this was the output from the fusible resistor, and this is a full bridge rectifier circuit. So the diodes conduct in only one direction, and for this circuit, for example, 1N400 diodes can be used. Now this full bridge rectifier circuit converts this given AC signal into this waveform, and after that as a filter capacitor is used which converts this waveform into an almost constant DC signal. Now we have to convert this DC signal that was generated in the previous step into a high frequency AC signal. An oscillator circuit is used for this purpose that produces 15 to 50 kilohertz PWM signal, that is DC to high voltage high frequency AC conversion, and this conversion to high frequency is required to reduce the size of capacitors and transformers required in the circuit. A driver IC and switching resistor is used in this circuit. So why is this frequency conversion is required? So as we have studied in our ELL101 course about the area product of a regular transformer, and we know that it is this area product represents the bulkiness of the transformer, and we see that it is inversely proportional to frequency at which the transformer operates. So that means that if the frequency will be very high, the area product will be low. So that means we can make smaller and smaller transistors that can fit into the casings of the mobile phones, and that is why we need to convert it into a very high frequency. And similarly large size capacitors will be required if such a conversion is not done. Now we have to step down the amplitude of the PWM signal. A flyback transformer, which is a switching transformer, is used for this purpose, which is shown over here, and that steps down the high voltage PWM signal into a 5 volt PWM signal. So what is a flyback transformer? A flyback transformer is used to generate high voltage signals at a high frequency. Many modern applications allow for high voltage designs up to 30 kilovolts that help reduce the component count in switching mode power supplies. The basic difference between a regular transformer and a flyback transformer lies in its design. The flyback transformer stores the input power during one phase of operation and then generates the kickback voltage during another phase, and this energy is stored temporarily in the magnetic field inside the flyback transformer. It operates at frequencies ranging from 20 kHz to 200 kHz. And this is the final step, which is conversion of 5 volt PWM signal into a DC voltage. A single diode rectifier circuit, which is shown over here, is used. So RL represents the mobile phone which is drawing the power, and V in is the PWM signal that we generated from the previous step, that is the step down PWM signal. And when this signal is high, the capacitor charges up, and parallelly the mobile phone is also drawing the current. And when the signal gets low, then the load resistor will draw current from the capacitor. So in this way we can assure that the an almost constant voltage is being supplied to the load, and the capacitor over here should have a high value of capacitance so that the drop in voltage across the capacitor is very less while it discharges. Now the actual circuit also requires a feedback mechanism so that we can ensure that the output voltage is fixed 5 volt and not any peaks of voltages or any jumps in voltages. So for that an optocoupler circuit is used as a feedback mechanism to ensure that the output voltage is 5 volts. An optocoupler is a device containing LED and phototransistor to give feedback from output side to input side while also maintaining electrical isolation. That is, in order to prevent any leakage, we do not want to have any electrical connections. So therefore this optocoupler is used, which does this feedback thing without the requirement of any electrical connection. And these are the references, and thank you for paying attention.